This video takes a look at Module 2, Lesson 7, Addition and Subtraction of Rational Numbers. Often using a number line will help with the addition and subtraction of rational numbers, which you'll see throughout the lesson. And just a reminder of what a rational number is. Rational numbers can be written as ratios, whereas irrational numbers cannot. So today you guys will apply the rules for adding and subtracting integers to rational numbers. So the only thing that's a little bit different with this lesson is we're going to have more fractions, mixed numbers, things like that. Okay? I know I've got this when you are able to accurately add and subtract positive and negative rational numbers, including fractions and mixed numbers. And our standard is 7 NSA 1D. Apply properties of operations as strategies to add and subtract rational numbers. For exercise 1, what I want you to do is read through this question, okay? Use some close reading strategies, meaning circle some important numbers, underline important information, box the question, and I just want you to solve it in the space provided, all right? Make sure you are using a number line to help model your answer. After you have done exercise 1, I will show you the steps to correctly answer it. And then we're going to look down at example 1 and model the same situation a little bit differently. So go ahead and try that and look back at the video when you are done. Hopefully for exercise 1, you got 8.5 years old. On the left here, I just set it up as 12 minus 3.5. And to the right here, I set it up as 12 plus negative 3.5. Because subtracting is the same as adding a negative. Down here, you can see the number line. I started at 0, went to 12, and then I took away that 3.5, and I ended up at 8.5 years old. So hopefully that's what you got here for exercise number 1. Most of the time, if not always, we start our arrows at 0. But in this case, our first number is 12. So why don't we instead just start our arrow at 12? Now, in order to do that, we need to label our number lines. I'm going to make these intervals 1, but I'm going to start with 0 here. So this is 1, 2, 3. I'm going to label every third, and I'll make sure it is directly lined up so it's neat and organized. So 0, 1, 2, 3, 4, 5. This would be 6 right there. Move it over a little bit. 7, 8, 9 right there. 10, 11, 12. Right there, 13, 14, 15. Now, it is okay for you guys to label every single one. All right, so you can have it 1, 2, 3, 4 all the way up, or 0, 1, 2, 3, 4. Now, we're going to place the tail of the arrow at 12. So the tail of the arrow is going to go here. Now, the length of the arrow is going to be 3.5. Because the absolute value of the negative 3.5 is 3.5. All right. So, and it's going to the left because I am adding a negative number or I'm taking away that 3.5. All right. So this would be 1 right here. This would be 2. This would be 3. And a half would be right between. So this right here is another way we can represent 8.5. In this example number 1, we're solving the same problem, but we're starting at 12 because our first integer is 12, and then we're just moving to the left 3.5. So we end up with 1 arrow instead of 2, excuse me. Now, both approaches are fine and correct, but the more strategies we have in our tool belt, the more type of problems we're able to attack. Now I want you to take a look at exercise 2 and try to apply the strategy we just used on the previous question in order to find the answer in the previous case It was a sum if we're talking about adding a negative, and it was a difference if we were just talking about subtracting. Here you're finding the sum because you're adding. Use the number line diagram in order to find the sum. When you're done, come back and check the video before we take a look down here at example number 2. For exercise 2, the sum is 2.5. What you'll see down here is the one arrow or one vector approach. Keep in mind it's not superior or better than using 2 vectors or arrows, but we're just looking at it a different way. I started at negative 2.5, and then I increased by 1, 2, 3, 4, 5. That put me right at 2.5, or I counted up by 5. Depends on how you want to look at it, but hopefully you got positive 2.5, and you were able to correctly model it on the number line. Example number 2 has us representing differences of rational numbers. So now we're looking at subtraction. Anytime you are subtracting with negatives, or really in general heading forward because your math skills are going to get more challenging, problems are going to get more challenging, the first step I always do, whether I actually write it down or I think it, is I rewrite the difference or subtraction as the sum, addition. So I always switch my subtraction problem into an addition problem. Now, if you're wondering why, it's because there are specific rules for adding integers. We know when you're adding integers and they're both negative, you just add them together and keep the sign. If you are adding integers and the signs are different, you subtract and you keep the sign of the bigger number. Or not the bigger number, but the number that's further from 0. We don't have those same subtraction rules, okay? But those same adding integer rules can apply to rational numbers. So if I rewrite this problem, it becomes 7 plus a negative 2.25. So that's already given me some information. What it's telling me immediately, because I took the time to rewrite that as addition, I know my answer will be negative because the negative is further from 0 than the positive. I also know I'm going to have to really subtract these two numbers or find the difference because the signs are different. So by just rewriting that question, it's giving me a lot of information. Okay? Now, if I'm going to represent this on this number line, we have to follow a few steps to find now the sum because we have switched our subtraction problem into an equivalent addition problem. I'm going to place the tail of the arrow at 1, okay? Because that's going to be my starting point. My first integer is 1. The next thing is the length of the arrow will be 2.25 because the absolute value of negative 2.25 is 2.25, right? So that second value tells me how long my arrow will be. And this is once again using that one arrow or one vector approach. Just a different strategy than using 2 arrows or vectors. Now the direction of the arrow is to the left since you are adding a negative. Ooh, sorry about the typo. You are adding a negative number to 1. All right? Now, what I want you to do is we're going to start with our 0. Let's say here. Let's make this 0 right there. Now, I want you to make your intervals quarters, meaning 1/4. So why don't you go ahead? I think you guys can handle the rest of this problem. Label by quarters, and then follow these steps to find the answer to this original problem. 1 minus 2.25, which we have changed to 1 plus a negative 2.25. So once you have completed your number line and used it to solve, come back and check the video to make sure you have done it correctly. First thing I want you to look at in your number line is making sure your intervals are correct. I told you to count by quarters, and the reason I wanted you to space out by quarters is based on the numbers we have. So I have a -2 1/4. So if I count by quarters, when I go to draw my vector to the left, it becomes easier to count -2 or 2 and then an extra quarter. So going from this point here, which is our 1, 4/4 is 1, which is our starting point, to -4/4, that represents 2, and this extra hop represents that extra quarter. So the answer you should have got was -5/4 or -1 1/4. Meaning our answer to this original problem of 1 minus 2 1/4 is actually -5/4 or -1 1/4. So with that logic and that new knowledge, I want you to go ahead and attempt exercise 3. Before you move forward and try 4, check your answer to exercise 3, because I don't want you to keep moving forward unless you're confident and know you're doing this right. So go ahead, do exercise 3, come back and check to make sure you did it right, and then you can move forward to exercise 4. For number 3, or exercise 3, hopefully you got a difference of 2 1/2. Keep in mind, we're finding difference because we are subtracting. We switch it to an addition problem, and then we find the sum of that. But the original problem is asking about subtraction. So that's the difference ultimately. Now, anytime you have those two subtraction or negatives back to back, you just switch it to a big plus. So that's why here you see -5 1/2 plus 8. That is 2 1/2, which is modeled right here on this number line with our vector starting at -5 1/2 and moving to the right 8 spaces, because that 8 ends up being positive once you switch it into an addition expression. Now, with that in mind, move forward, try exercise 4. Check the video when you are done with all parts of exercise 4. The 5 questions in exercise 4 are really pushing us to our goal of the lesson, which, remember, our goal of the lesson, if I go back to our original slide up here, our goal, and you know you have this when you are able to accurately add and subtract positive and negative rational numbers, including fractions and mixed numbers. So if we go back to what exercise 4 is asking about down here, this is really testing that ability. So if you got these 5 questions right, you're really on track. If not, we still have some work to do, okay? Now, A, you should have got -3 1/4. I know that my answer is negative because my negative is further from 0 than my positive here. And really, you subtract. Now, on a number line, you would start at -6 if we're using the one vector approach, and you would move to the right 5 1/4. That ends up at -3 1/4. Now, for B, if you use that keep flip chain, these two minuses or negatives, whatever you want to look at it, become a positive. So really, it's just 7 plus 9/10, which is 7 9/10. Now, on a number line, I split it up by 1/10 apiece. My vector started at 7. I went 9/10 to the right because now the 9/10 is positive, and I end up at 7 9/10. Moving down for C, C immediately when I'm thinking, my positive is further from 0 than my negative. My answer will be positive, and I'm going to need to subtract. Now, if I'm just looking at a number line, I'm starting at 2 1/2, and I'm going to the left because the second integer, or the second rational number, this is not an integer here, this is a rational number, but our second rational number is negative, so I move to the left 1/2, and I end up right at 2. So the sum here is 2. Now for D, when I'm looking at this sum, once again, I notice my signs are different. I know I will have to subtract, but I know my positive is further from 0 than this negative rational number, so I know my answer will be positive. In terms of my number line, I'm starting at -1/4, and I am moving to the right because the second number is positive, and I'm moving 4. You end up at 3 3/4, or 3 3/4. For E, these two negatives once again make a plus, so you're at basically 1/2 plus 3, which hopefully we know is 3 1/2. on our number line, we are starting at a half and moving to the right 3 because that negative makes a plus, making that second value, that second, it is an integer in this case. 3 is an integer, positive. So I'm moving to the right. Exercise 5, there are 3 parts, and exercise 5 is even pushing your thinking further because it's asking you to apply the knowledge you have now gained about adding and subtracting rational numbers and apply it to word problems. So once again, I'm going to challenge you to go through and answer these without support. The only thing that's going to be here after you're done really is the answers and a quick explanation. Use your close reading strategies. Read through it carefully. Make sure you are modeling it. You're first creating an equation, and then you're modeling that with a number line diagram. When you're reading through, make sure you're reading carefully in order to pick the correct operation. And make sure you know whether numbers represent positives or negatives. Okay? Once you have finished these 3 exercise questions, come back, check the video to make sure you did them correctly. And then the last and final step of this lesson will be the problem set. For part A of exercise 5, you should have got an answer of she still owes him $1.50. So that's like a negative $1.50 towards Samantha. Owing this $7 is a negative, and getting paid $5.50 is a positive. So I have -7 plus $5.50. Okay. Now, with that set on the number line, we end up at -150, meaning she still owes $1.50. She didn't get to the positive yet. For B, 12 is our starting point. The gas tank contains that much, so the 12 is a positive, and the car is consuming 10 and 1/8. So that 10 and 1/8 is a negative. So I have the expression 12 plus -10 and 1/8. Ultimately, when we model this on a number line, you end up with 1 7/8. So the correct answer is there are 1 7/8 gallon of gas left in the tank. Moving down to C. C, I drew a vertical number line, which we'll get to in a second, because it was dealing with how close you are to a water surface. And for me, when I think of a water surface, I always think vertically on a vertical numbered line, not really horizontally. Now, either is correct, but it helps me to visualize water as vertical. Now, a fish swimming below is a negative. Now, it went below, again, by 5 1/4 feet from where it was before. So that's adding an additional -5 1/4. So basically, this fish is at -3 1/2, and then went even further down by -5 1/4. So you have to add that negative onto the negative rational number that already exists. So our answer here is -8 3/4. And you can see my number line here. I'm starting at -3 1/2 with the one vector approach. Keep that in mind. If we had 2 vectors, you would start at 0. And we went down -5 1/4, and I end up at -8 3/4. So the fish is 8 3/4 feet below the water surface, below sea level here at 0. Now, we're going to take a quick look at the lesson summary before you guys tackle these 6 problem set questions. The rules for adding and subtracting integers can be extended to rational numbers. And that's the key in the understanding for this lesson, is those rules of switching the subtraction to addition and then using those addition rules. Same sign, you find the sum, meaning you add. In different signs, you find the difference, meaning you subtract. Those apply to rational numbers, meaning fractions, decimals, mixed numbers, all of those things. Okay? Now, we've also learned the one tail or the one vector, the one arrow approach, okay? You can put the tail end of the arrow on the first integer or the first rational number and then just draw it based on how long the second rational number is. You just got to make sure you're going in the correct direction, okay? Now, make sure you're rewriting subtraction problems as addition problems. The reason being, we have distinct rules that help us solve addition problems. But we don't really have distinct rules to help solve for subtraction problems other than first change it to addition and then use our addition rules. Okay? So keep these three key points in mind as you go through these six problem set questions. So you're going to read through these. They are all word problems, so make sure we're using those close reading strategies. For all of these, you probably need a separate sheet because what I'm asking you to do is create a number line for each of these and write the addition or subtraction and then addition equation that represents all 6 of these problems. Then ultimately, obviously, come up with an answer. This is that opportunity in addition to those previous exercises to make sure we are reaching that lesson goal, being able to add and subtract rational numbers. When you are done with these 6, come back and check your work to ensure you have mastered this lesson before you move on to the next lesson. For problem set question 1, you should have got 9.5. The 15.5 is a positive, and then the 6 feet down represents a negative, so I have 15.5 plus -6, that gets 9.5. Notice writing the answer in a complete sentence because it's a word problem. The bird is 9.5 feet above ground. You can see the number line here. My arrow starting at 15.5 and going to the left or down 6 units. Number 2, you should have got negative 75 hundredths, which represents owing 75 cents. She owed her grandfather $225. That's a negative $225, and paid him $150. So that's a positive $150. That ends up being a negative 75 hundredths, which means Maria still owes her grandfather 75 cents. For the number line, the tail starts at -2 1/4, and it increases by $1.50, which still leaves it in the negatives, but it's at -3/4, which represents the negative 75 cents. For C, the trail as a whole is 4 2/10 miles long, and he plans to stop after he completes 1 6/10. So basically we have kind of a straightforward subtraction problem. 4 2/10 minus 1 6/10. Now, subtracting is the same as adding a negative. So this equation is really the same as 4 2/10 plus negative 1 6/10. So basically the arrow would start at the tail end at 4 2/10 and it would go to the left 1 6/10 and end up at 2 6/10, meaning Jake will be 2 6/10 miles from the top of the canyon. Number 4, Sonia is 4/10 of the miles from the finish line. She noticed her friend has fallen. She runs 1/10 of a mile back. So both of these are actually representing negative values here. So Sonia will ultimately be 5/10 of a mile from the finish line because when you add these two negatives, you get a negative 5/10. Notice my number line here. I set up my intervals being tenths because I know I was basically dealing with tenths here in my word problem. Wouldn't make much sense to count by anything but tenths here for number 4. For number 5 here, a balance of 200 is a positive and a debit is a negative. So I'm at 200 plus negative $317.25. That leaves us at negative $117.25. So Mr. Henderson's checking account balance here is actually going to be in the negatives, meaning he's going to owe money. It's going to be negative $117.25. Notice my arrow starting at 200 and going to the left because it is decreasing. And I actually end up right here at the negative 117.25. I counted by 20s on my interval here on this number line because these numbers are much larger. If you set up intervals by 1 here, it would have taken you quite a bit of time to set up this number line. Now, number 6, the temperature is -4. That is obviously a negative, and it falls 4 degrees. So that is also a negative. So we have -4 plus negative, or -3, plus -4 when you switch it to an addition expression, which is -7. 6 was arguably maybe the easiest problem. and your intervals could be 1 here in your number line because you're dealing with smaller interval numbers that happen to be integers and whole numbers. Okay, so it would start at -3, go to the left 4, you end up at -7, so the temperature is -7. So if you were able to correctly answer these 6 problem set problems, you have for sure mastered the lesson on being able to add and subtract rational numbers. You have been able to apply what you learned previously about adding and subtracting integers and extended it to adding and subtracting with the rational numbers. So you are more than prepared to move forward to the next lesson.